Hey everyone, it's Justin again. Previously, we learned how to graph inequalities. And in this video, we're going to use those graphs to easily tell what is and isn't a solution. Here's one of the inequalities that we graphed in the last video. So now for the big question. Is negative 3, 2 a solution? On an inequality graph, the line separates the solutions from the non-solutions, and we shade the side where the solutions are. So is this point, negative 3, 2, a solution? No, because it's not in the shaded area. It's that easy. Think of it this way. With equations, anything on the purple line is a solution. But with inequalities, the purple isn't just a line, it's an entire area of the graph. And any point in that purple area is a solution. So what about the point 1, 2? Is that a solution to this inequality? Yes, because it's in the shaded area. Here's a tricky one. Is negative 3, negative 5 a solution? Here's the point. Right on top of the line. The solid line. Oh, that's right. A solid line means any point on the line does count as a solution. If points on the line didn't count, the line would be dashed. Here's another graph from the last video. Is 2, 5 a solution? Sure, because it's right here in the shaded area. All right, what about negative 3, 1? That's nowhere near the shaded area. It couldn't possibly be a solution. Is 1, 2 a solution? It is on the line after all, but the line is dashed, meaning the points on the line do not count as solutions. Remember, the line is where both sides of the inequality will be equal. If it's an or equal to inequality, then that's fine, but inequalities that require strictly greater than or strictly less than don't want the sides equal, so the points on the line don't work. Graphing is especially useful when you need to check a bunch of solutions quickly. After all, who wants to plug in and simplify 6 different points? That would take forever. Instead, we can graph a y-intercept of 2, draw a line that rises 2 units and runs 3, make the line dashed since the inequality is strictly less than, and plug in 0, 0 to find out that we shade below the line. Now that we have a graph of the inequality, we can quickly tell what is and isn't a solution. Negative 1, 4? Not in the shaded area, not a solution. 3, 0. It's shaded, so that's a solution. Negative 3, 0. Not a solution because it's on the dashed line. 1, negative 2? That's a solution. 3, 4? Not a solution. And negative 5, negative 1? Not a solution. We were able to test 6 different points, and the only point we ever had to plug in was 0, 0 to know where the shaded side was. That's all there is to testing solutions using a graph. In the next video, we're going to go backwards, using graphs to write the inequality that goes with them. See you then.